Hello, everyone. This is track two of day two of the 2022 AHC Resilience Summit. My name is John Molnar. I'm the Program Management Office Director for the All Hazards Consortium. I've been working at the AHC for 15 years now, and I will quickly move forward to the first track of the second day here, which gets into using technology and information for data-driven decision-making for planners. Our moderator, who I will introduce, and then Carrie, you can get on with the panelists. But Carrie Trapazza is a GIS director at Ben-Ear Solutions. She is one of the key leading Esri technology solutions providers within this arena, and is a key member of the AHC GIS Working Group Committee that works on a lot of the various data sets and data solutions that are integrated into the SICE Esri platform that the AHC utilizes, and Carrie provides a ton of input into that arena. Carrie, if I can transfer it over to you and have at it.
Thanks, Tom. Thanks, John. I was looking at Tom when I said that. Apologies. Thanks, John. So today, on using technology and information for data-driven decision-making for planners, we're going to have Jim Williams. So he is the Public-Private Partnership Operations Officer with the Louisiana Business Emergency Operations Center at University of Louisiana at Lafayette. And we have Raju Gattamukkala, who is the Director of Research at Informatics Research Institute, also at the University of Louisiana at Lafayette. So with that, I'm going to turn it over to our speakers. A couple of notes. If you have questions, please drop them in the chat. We will have time either throughout with natural pauses for questions as they come up, and definitely have time at the end. We are going to modify our session until 2 p.m. So it's going to be a little bit different than originally planned, but we'll still try to give a couple of minutes at the end for questions. With that, Jim, Raju, all yours.
Jim, you want?
Hey, thanks, Gary. Appreciate it. So what I'd like to do is talk about what we faced in going into Hurricane Ida, and kind of set the stage for what we did, and how we used data to make decisions to support the response to Hurricane Ida. So going into Hurricane Ida, we, at the Business EOC, I'm in a unique position here in Louisiana that directly across the hall, I have some really smart data folks that can help us answer questions. So as we were going into Hurricane Ida, we didn't really, at the state level or at the Business EOC level, weren't able to really see ourselves and see the state. So, we had several days because, hurricanes have a known track. And we started trying to find ways to be able to see how businesses in the strike zone were going to be affected, and what businesses were going to be affected. So right after the storm hit, we, as per kind of the normal procedures in Louisiana, we activated something called the Fuels Task Force. And what the Fuels Task Force does is provides information to the governor and to the director of our governor's office of Homeland Security to make decisions on how to be able to assign resources in response to the hurricane. So at that point, the members of the Fuels Task Force include the Department of Natural Resources, the Department of Agriculture and Forestry, because Agriculture and Forestry handles all of the emergency operations fuel for the state. So it's a couple of, the Louisiana National Guard is also part of the Fuels Task Force. So as we started going forward during this Fuels Task Force, what we were able to note was the emergency response fuel was in a good position. They had good supply. They had the amount of trucks that they needed available, and they were able to store the fuel so that they could dispense it out to the first responders as they were going forward. From there, we noted that there was a significant increase to the fuel supply chain on the private sector side. And this is, as we kind of went and looked back on it, and we'll kind of discuss that in a minute. But we didn't know how much the demand increased, and we really didn't see, we were in the response phase, we're really trying to make assessments on how far the damage is. So as that information started coming in, we were really looking for a live feed. And so initially in the first 24 to 48 hours, we used the Fleet Movement app provided through AHC to be able to see ourselves and see the state. And what we were really trying to determine were where can we apply assets to help the response. And so that's where we stood at right there. But as great as the data feed was coming from AHC, we weren't really able to manipulate the data to be able to start answering some additional questions that were being posed to us during the fuels task force. So I'm going to turn it over to Raju and kind of talk how we started building the data set and then going forward from there.
All right. Thank you, Jim. So I think, so if I have to go over the different types of data sets we use, and so we did receive some data sets from AHC, and we, again, so first let me talk about the different types of data sets we use. I think the specific problem that we were trying to solve, again, we looked at a number of problems, but one specific problem was related to fuel, right? Because what happened was people, so the hurricane actually knocked out power in a lot of these areas. Some people stayed, some people left. I think as Jim was mentioning earlier, the fuel supply chain was affected drastically. So one thing, the fuel task force and the BEOC, Jim and team, really wanted to understand, number one, what is the demand going to be for fuel across these gas stations at different areas that were affected, number one. Number two, what is the current status of these gas stations, right? What does the fuel availability look like, right? Number three, some gas stations may have fuel, but they did not have power. So that means if the state really wanted to distribute generators, which of these gas stations really, do we really need to give generators so they can come back up and run? And the other question was, some of these gas stations have power, but they did not have fuel, okay? So these were the questions they wanted to understand, and obviously it's a constantly changing event, and which means as the event is, so as the event is changing, the situation on the ground is also constantly changing, right? Which means that some of these gas stations may have fuel now, but then they may not have fuel in 6 hours from now. You see, so it's not. I think you all would agree that it's really not an easy problem to solve. But I think we did the best we could, and to solve this, right? And I think the first type of data that we collected were about gas stations. So when we talk about gas stations, it is about the number one, where are these gas stations located? What is their status, right? Are they open, they're closed, they have generator, they don't have generator? And also, most importantly, is their contact information of these gas station owners. So that was one type of data set, right? To the gas stations itself, number of gas stations, the gas station data, right? And then the second was related to power outages, right? Power outages, both to understand what gas stations were affected and also to try to understand what kind of demand would there be in a given area, given that, so much area doesn't have power. So we looked at the power outage information. We looked at the evacuation information, how many, what percentage of parish approximately evacuated. We also tried to understand to some extent, we also wanted to understand, okay, what does foot traffic to these different gas stations really look like? And in order for us to understand that, we use some mobility data to kind of understand and categorize them. Hey, look, this is a high foot traffic gas station, medium foot traffic gas station, and low foot traffic gas stations. So those are kind of some high level type of data sets we used. And I think beyond AHC, we got some data from the governor's office. We tried to gather the public service, get data from the public service commission, from the FEMA NBEOC. We got the data from cell phone companies, anonymized cell phone data, again, at an aggregated level to understand what the mobility dynamics looks like. We also, work with some other private partners as well, because again, some of the data sets that we're trying to use is not just about the hazard itself, but about, specifically about the gas stations, their status, the power outage, the behavior, the dynamics of how people are moving, what the consumptions look like, and so on. So I think, so those are some different types of data sets that we've used, and the different sources. I mean, we used a number, we have like 10 different sources that we used to compile all of this data, primarily because we were actually building on some of the prior work that we've done a few years ago to develop a fuel demand and fuel deficit prediction for the state of Louisiana. So that was something that we did prior a few years back, and we kind of used some of the most recent data sets that were available at our disposal. So those are some data sets. Jim, back to you. You're muted, Jim. Can you please unmute?
Yep, I got you. Thank you. So what we did is, once we were able to identify the data sets we needed, and we started populating it into a GIS format so that we could see what we determined were fuel deserts, and that was fuel deserts. In some of the rural areas, that might be an operational gas station within 10 miles, and the geography of that area that was hit with the Hurricane Ida, was you would have, really one line of communication going in and out of those areas. So if you lost a gas station along that area, it may be 20 miles or more before you could even get to another gas station. In some of the more urban areas, because the widespread power outage during Hurricane Ida, at the highest point, there were over 1 million customers out of power. And everybody kind of knows the dynamics of what a customer looks like. So what we did was we identified these deserts, these fuel deserts, and then we used a tool to be able to make the data anonymous, so that, as a government entity that could potentially be utilizing public resources to assist a private entity, we cannot show any favoritism. So we anonymize the data, and then by using these algorithms created by Dr. Raju and his team, we were able to make recommendations to the governor that says the most good can be affected if we put generators at these locations. And as Dr. Raju mentioned, this was a living, breathing thing as it went along, because as power starts to come back on in some places, then we need to take those resources and reassign them to other locations that were heavily affected. And Dr. Raju and his team,
Jim, may I ask,
did a great job.
Jim,
Yep.
are you trying to show some slides?
Nope.
Okay. All right. I just want to make sure. Thanks.
No. So their team really, by making the data anonymous, we can make decisions based on the need in that affected area, and without having any type of priority given to a selected entity. And then that grew into over time as the recovery efforts continued. So that's, in this kind of shortened scenario for this presentation, that's kind of the background of how we use the data, how AHC kind of helped us be able to initially see ourselves, because we had not had any of the live data feeds that we needed. And at that point in time, the AHC data, we could not manipulate it to be able to answer questions that were specific to our leadership. And then Dr. Raju's team, how they use the live data feeds to make it anonymous, to be able to make, and that's really, as a government response entity, that's one of the big things that we have to make sure that we're doing, is not showing any favoritism to any one particular organization. And then going forward, how the environment changed during the recovery effort. So, Carrie, I know we kind of shortened this thing up, but I guess we'll leave a few minutes for some questions.
Hi, everyone. Yeah, so if you have any questions for Jim or Raju, please put them in the chat. So there was one that came in. So how did you come up with the algorithm to figure this out? I think you mentioned like a 10-mile area for your fuel desert, but, looking at the other data, just kind of how did you guys, come up with this?
So that's a very, very good question, right? So I think, let me separate this into two different parts. First, we tried to do this in a very short time, okay? Because this really came up. I mean, Jim and, not my office, and said, look, we need to help the governor, the secretary, DNR, and so on. So as a background to this, I think back in 2000, I believe it was 2015, 16 timeframe, we actually developed a fuel demand prediction model for the state of Louisiana. So DNR, the Department of Natural Resources, actually uses the fuel, the fuel estimates provided by our team during evacuation, right? Fuel estimates specifically on the evacuation highway. So we've helped DNR for several hurricanes in the past, and GOSEP through the BEOC that Jim manages now. So we've helped the fuel team and the Louisiana Department of Natural Resources and the governor's office, with estimates on, hey, look, this is what the demand is going to look like. This is what the deficit is going to look like. So we've provided those estimates historically using a model that we developed here that actually combines the transportation model, the evacuee behavior, fuel behavior, and a bunch of things, okay? So we developed this model and we had this model. But then the world has changed in the past 8-10 years significantly, right? I mean, the gas station data has changed. The mobility, we have access to new data sets. The approach has changed. Anyway, so that's the background. So we use some ideas, techniques from there, and specifically for specifically trying to answer a specific question, which is, how did you determine the specific island, right, where the fuel deficit is? We kind of looked at several factors in our algorithm. One thing we looked at is the population density, of course. We took that into account, number one. We looked at the number of the percentage of population that has evacuated, in that particular zip code or in that particular, not zip code, but in that particular parish. We also looked at, within a 10-mile radius, how many gas stations are there, right? And then we looked at the ratio of the population in that area and the number of gas stations. So what this would tell us is, if there are only 5 gas stations open, right, within the 10-mile radius versus 10 versus 2, you can easily determine that, hey, look, this is a desert here, isn't it? So that was, we did some spatiotemporal GIS analysis to kind of determine that. So that's how, again, that's one key component, right, with respect to how we determine the area, the island, right, the desert, if you will, right, with respect to how, where the demand or deficit is likely to be. So we also looked at some other things like, the foot traffic and, all of that stuff. But these are, I would say, the main factors that we looked at.
Great,
Looks like there is another question here.
Yep, there is another question. So how do you maintain anonymity when you must balance support and resources? Understanding the need to be fair, there have to be other variables. So can you speak to that?
You want to
so
take
one
this?
of the data feeds. Yeah, I'll take a little bit of this one, Raju. So one of the data feeds that we got from the NBOC provided some of the Dun & Bradstreet data showing which gas stations were operational, because that was really important on the operations side. Is we don't want to send a resource to something that's already open. But in one of the data feeds, it identified the business name. So we basically omitted that column to be able to say, we don't care who it is. We just care that it's a gas station. And then looking at some of the other feeds, it said the gas station is open and the gas station has fuel but no power. Then then add that to the algorithm that says this is a fuel desert. And if all of those stars lined up, then we made a recommendation to the leadership that we need to send a resource to that location. So it was a combination of a couple of different things, but we just really basically from the data feed that we got from the NBOC, we just omitted the name of the business.
Right.
Very good. So we have about 3 minutes left. We have time for one more question. If anyone has any additional questions. And Raju and Jim, if you have anything additional in the last 2 minutes now.
Yeah. So if there's no further questions, then, the kind of wrap up was, I have a unique capability of being able to walk across the hall to talk to Dr. Raju and his team. And I know that a lot of other states and my peers do not have that luxury. But when we are able to take live data feeds and be able to apply some analytics to it and some anonymity to it, to be able to provide answers to questions asked by our leadership, to be able to provide resources and kind of help mitigate some of the suffering that was out there. And additionally, we're able to use some of that data kind of going forward as we're looking at, hey, do we need to change some legislation to be able to say, hey, you need to have some of these resources already on hand as a private entity to be able to do some mitigation and make businesses more resilient in the future.
Yep.
Great, thank you. Anything additional for Jim or Raju? All right, folks, thank you for attending. Thank you for being fluid in changing the link and coming in a little bit later. And thanks, Jim and Raju, for shortening the session. And with that, John, I'm gonna turn it back over to you.
Thank you. Thank you all.
Hey, Carrie, let me just jump in real quick. We're gonna come back to this session and do a full-length version. Raju, I appreciate you guys hanging in with us. We had some Zoom issues, and we'll make sure that's available in the recording. Okay, thank you very much. Very good. Thank you. John, I'll turn it back to you.